if you would recall, we've been taking some time to learn the unit circle all the way around. What we want to have are the angle measures in degrees, the angle measures in radians, and the exact values of the coordinates for any angle on a quadrant or that has a reference angle of 30, 45, or 60 degrees, also known as pi over 6, pi over 4, and pi over 3 radians. For the exact values of the coordinates, it's helpful to know what values we have available. And it's 0, root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, and root 4 over 2. 0, root 0 over 2 is better known as 0. Root 1 over 2 is better known as a half. Root 2 over 2 is root 4 over 2 is better known as 1. But those are the values that we want to remember, the exact values that we want to know. The two irrational ones, root 3 over 2 and root 2 over 2, we want to know their decimal approximation as well. Root 3 over 2 is approximately 0.8660, and root 2 over 2 is approximately 0.7071. This is your trigonometry times table. Unit circle is your trigonometry times table. What we want is random access all the way around. So for example, if I drop an angle like 315 degrees on you, I want you to know things like the reference angle, the value in radians, the reference angle in radians, sine and cosine of that angle. So if we have a 315 degree angle, some things that we'll want to know, we'll want to recognize 315. What reference angle are we talking about? 45. So the reference angle, sometimes we write that as theta with a subscript of r. So theta sub r is 45 degrees. That's one thing that we want to immediately know about the angle that we're thinking of. With a reference angle of 45 degrees, what are the coordinates on the unit circle? Because that'll tell us the cosine of theta. Theta is 3 degrees. So now that we know that there's a 45 degree reference angle, what is the cosine of 315? Root 2 over 2. And is it positive or negative? Why is it positive? We're in the fourth quadrant, and cosine is positive in the fourth quadrant because x is positive in the fourth quadrant. So that's another thing that we want to know. This is in quadrant 4. So the 45 degrees tells us that the 45 degree reference angle tells us that the value of the cosine of 315 is root 2 over 2. The quadrant tells us that we should use the positive. What about the sine of 315? (45) is the weird one where the cosine and the sine are the same. That's where cosine and sine meet up at 45 degrees. So we're still going to have a root 2 over 2. But what sign are we going to use? Negative. In the fourth quadrant, y is negative. So the value, the absolute value we're getting from the reference angle and the trig function, the sine we're getting from the quadrant and the trig function. The absolute value that we're looking for, we get from the reference angle and the trig function, and then the sine is from the trig quadrant and the trig function. You should also be able to read this in radians. So 315 degrees, how many radians is that? So it's got a 45-degree reference angle. What's the denominator going to be? 4. Because a 45-degree angle is a pi over 4 radian angle. So if we've got a reference angle of 45, that means we're going to have some multiple of pi over 4. And it's going to be an odd multiple of pi over 4. So we just have to think about here's 1 pi over 4. Here's 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. The even multiples of pi over 4 are going to land on the quadrants, and the even will cancel out with 4 and make a 2 land on the quadrants. So the ones that we're going to be interested in are 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So pi over 4 in the fourth quadrant is 7 pi over 4 radians. Our reference angle (45 degrees) is telling us the pi over 4. That denominator is going to be consistent. Questions? All this information happens just by bringing up 315 degrees. How's everyone okay? That's fine. What about the angle 5 pi over 3? What's our reference angle in radians? Our reference angle. 60 is in degrees, and what's 60 in radians? Pi over 3. We can see that because I got 5 pi over 3. I don't have anything to simplify in the fraction. The denominator will tell you which one we're dealing with. So we might be thinking in our minds, we're like, oh, this is 5 times, this is a 60-degree reference angle. That tells us that it's a pi over 3 reference angle. So if I write x sub r, pi over 3, that's our reference angle. What quadrant are we in with 5 pi over 3? What angle is this? 4 is correct. We are in the fourth quadrant. And what's pi over, what's 60 degrees in the fourth quadrant? So what angle in degrees is this? 300. Awesome. And it says it right there. Pi over 3 is the same as 60. If I've got 5 pi over 3, that's 560 or 5 60s. So that is 300. 5 times 60 is 300. And let's see, we are in quadrant 4. So if I want the cosine and sine, the coordinates of the point corresponding to 5 pi over 3 radians, the cosine and the sines we get from the quadrants and the trig function.
Cosine is positive in the fourth quadrant, sine is negative in the fourth quadrant. What value goes with the cosine of 5 pi over 3? It's cosine of 60-degree reference angle. What value are we dealing with? We got 0, we got a half, we got a root 2 over 2, we got a root 3 over 2, we got a 1. Those are our possibilities. 5 possibilities. What is cosine? So, we use our calculator. If we ever forget, we can just grab our calculator. We get a 0.5, but we don't want to write that. We want to make it look like we remember. So we're going to write the fraction. What fraction is 0.5? 1/2. So if the cosine is got a 1/2, what's the sine got? What's the sine of 5 pi over 3? Negative root 3 over 2. With cosine and sine, if one of them is a half, the other one is root 3 over 2. Because that's how the points work. Remember, these are points on a unit circle. And we had just talked about our trig identities. Say cosine squared theta plus sine squared theta is equal to 1. If I take the cosine of 1/2 and then square it, and add that to the square root, negative root 3 over 2 and square that, we should get 1. Half squared is a fourth. The square root of 3 squared is 3, and the 2 squared is a 4. So that trig identity checks out. All this came about because we looked at the 5 pi over 3. We immediately saw our reference angle of pi over 3 because the denominator was still a 3. And that associated with 60 degrees. And so all the stuff that we know about 60 degrees came up. I shouldn't say it came up because that's like a vomiting thing. So that might make people vomit. Question. In my calculator, the way I just did it was kind of cheated because I'm like in degree mode. So I was just like, oh, 300 cosine. But if I wanted to, if I was in radian mode and I wanted to do radians, I have a pi button. So I just do 5 times pi divided by 3 and then hit the cosine of that. So we have a pi button on our calculator sheets. The reason that we want to recognize some decimal equivalents is we know what our list of possible answers are. We know 0, a half, root 2 over 2, root 3 over 2, or 1. If I happen to do the sine of 300 or 5 pi divided by 3. If I did the sine of this, I would get 0.8660, and I would want to recognize that number as my calculator saying the square root of 3 over 2. Calculator doesn't know square root of 3 over 2. But if I take this number and square it, I get 0.75. So that's 3 over 4. Any other questions? In these last two examples, I handed you an angle, and then we asked for stuff about that angle. But we want to have random access. We want to be able to come in from any point. So let's suppose that I say find x. Now let's say find theta. We'll do the problem in degrees such that cosine theta is negative root 3 over 2 for theta between 0 and 360. So in this case, we're going to be solving an equation. I want to find theta such that cosine of theta is negative root 3 over 2, but only for theta between 0 and 360. We're getting information the same way that we had information before. The sine is going to come from the quadrants and the trig function. The value is going to come from the trig function and the reference angle. Those are the relationships that we have. Quadrants, trig function, reference angle. So here we have a cosine, and we're looking for an angle where the cosine is negative. So what quadrants are we talking about? Because cosine is negative, cosine is positive in quadrant 4. Remember, cosine goes with x. Here's x. Cosine is positive when x is positive. So cosine is positive here. All of them are positive here. Sine is positive when y is positive. So sine is positive in first quadrant and the second quadrants. Tangent is positive when x and y are the same sign. So in first and third quadrant. So cosine is negative when x is negative. So we have cosine is negative in the second quadrant and the third quadrant. Quadrant information from the trig function and the sine. The cosine and root 3 over 2 are going to tell us a particular reference angle. What, what angle has a cosine of root 3 over 2? $30, $45, or $60? We're all armed with calculators. We don't get to be stuck very long. So if I got 30, cosine of 30 is root 3 over 2. If I had 60, cosine of 60 is 0.5. Cosine of 45 is root 2 over 2. Not allowed to stay stuck for very long. So if I have cosine and root 3 over 2, we know we're talking about a 30-degree reference angle. Now to solve the problem, I want to take the 30-degree reference angle and put it in quadrant 2 and quadrant 3. So the thetas that we're looking for are 30 degrees in quadrant 2 and 30 degrees in quadrant 3. What's 30 degrees in quadrant 2? What angle is that? Now 120 is too far up. 150. So 180 is in between 2 and 3. I want to go down 30 and up 30. So 180 minus 30 is going to be 150. And what's 30 degrees in quadrant 3? It's going to be 180 plus 30, 210. How's everybody okay? If we visualize what this question has, if we visualize what's going on with this question, imagine the unit circle. When we look at cosine of theta is negative root 3 over 2, we associate cosine with the x coordinate. So our x coordinate is negative root 3 over 2. So I'm going to go to an x coordinate of negative root 3 over 2 and find those two angles. Negative root 3 over 2 is the last one that we get to before we get to a negative 1, because that's 0.8660. So that tells us that's going to be the one that's farther away. That's going to be the 150 and the 210. The 120 is too far up. That's where we have x of 1/2 and of negative 1/2. So if we think about the x values, we have x is +1, then root 3 over 2, root 2 over 2, 1/2, 0, negative 1/2, negative root 2 over 2, negative root 3 over 2, negative 1. The quadrant and the trig function are the sign. You get the quadrants and the trig function. The value and the trig function give you the reference angle. So here we have another type of equation. We know we're going to have two values because there are two places where sine is positive. What are the two quadrants where sine is positive? What quadrants are we thinking of? Quadrant 1 and quadrant 2. Because the quadrant 1 and quadrant 2, that's where sine is positive. The sine is positive where the y coordinates are positive. What is our reference angle when we have sine and root 2 over 2? Actually, just with the root 2 over 2, what's our reference angle? 45 degrees. Oh, the problem's in radians though. So what's 45 degrees in radians? .45 is correct, 40, but that's in degrees, right? And right now we're speaking radians. So we're just going to replace that with the radian version. So I'm going to put pi over 4 in quadrant 1 and quadrant 2. Quadrant 1's our favorite. The angles are their own reference angle, so pi over 4. But what's pi over 4 in quadrant 2? 3 pi over 4. So pi over 4 and 3 pi over 4. "45 degrees in quadrant 1 and quadrant 2. So we might be thinking in degrees. If we think in degrees, 45 in quadrant 1 is 45. And 45 in quadrant 2 is 135. And the 135 is 3 times 45. Over 4 goes to 45, over 3 goes to 60, over 6 goes to 30. It only seems like a lot to remember because it's a lot to remember. You have to remember all of it in its exact values. All right, let's take a quick break and come back and talk more about knowing our unit circle all the way around.